Alright, example number 5 in section 4.3. I'm creating a new video because I didn't like my lack of confidence the first time I recorded this. So, our instructions don't tell us whether we should solve it for exact answers or if we should solve approximate answers. So what I'm thinking is we should do both. It also doesn't tell us whether we should do degrees or whether we should do radians. So if you want, we can do both of those as well. But then we have to change our mode of our calculator. So I'm going to go ahead and add to these instructions that we're going to do exact answers and we're going to do approximates. To 4 decimal places. Alright, so to do exact answers, theta is going to be found by taking the inverse sign of 1/3. And that's a positive ratio, so that will give us a positive angle. So that's a quadrant 1 angle, right? And then we can have infinitely many of those. So infinitely many, we would add 2 pi k to that quadrant 1 answer. So we have infinitely many quadrant 1 answers. I can approximate this in just a second. We're also going to have a quadrant 2 answer. So here's our quadrant 1 answer. But we also need a quadrant 2 answer. And the quadrant 2 answer is going to take the angle we get in quadrant 1, and that becomes our reference angle in quadrant 2. So to find the actual angle from the reference angle in quadrant 2, we subtract that angle from 180 degrees, or pi radians. So since I'm doing this in radians, let's do it in radians. So I'm going to do pi minus the angle from quadrant 1, because that's our reference angle, and that will give us our quadrant 2 angle. Now, of course, what happens to 3? Of course, we also need infinitely many quadrant 2 angles, so again, we add our 2 pi k. Okay, so those are the exact answers, okay? Exact and infinitely many answers. Let's go ahead and do approximate answers for theta. So approximately, we would take this and put it in our calculator and get the angle. I know I have this calculated already when I did this the other time. But I'm going to go ahead and find it again. So inverse sine of 1/3. My calculator's in radians, so that's going to give me 0.3398. And of course, I can keep adding 2 pi values to that. And then to find the quadrant 2, I would take that answer and subtract it from pi, which has to be less than 3.14 because we're subtracting from pi. So that would be 2.8018 because it was a 7 5, so it rounds up to an 8 plus 2 pi k. So that would be infinitely many approximate answers. Sometimes, and you're going to see this in section 4, they ask us just to find the answers from 0 to 2 pi, in which case we wouldn't have to do the 2 pi k in the last step, because our answers would just be the 0.3398 and the 2.8018. Or it would just be exactly these answers without this part. That's the range that we're giving our answers in. Okay, let's look at tangent. So again, just like in the last one, we are going to do the inverse tangent of -2. That gives us a quadrant 4 angle, right? And tangent is going to be negative in quadrant 2 and quadrant 4. So then if we want to find other values besides just the quadrant 4 angle, we can take that quadrant 4 angle and add values of pi to it. So times k, any integer value of k. Alright, so that's our exact answer. So approximate answer would be, let's throw this in a calculator. So inverse tangent of -2 So that would be a quadrant 4 angle of negative 1.1071 plus values of pi k. If you'd rather not start with a negative angle, you could always add pi to that to begin with and start with a quadrant 2 angle instead. 2.0344 plus pi k, and those two are exactly the same answer. It's just that one starts in quadrant 4 before it starts adding values of pi, and the other one starts in quadrant 2 before it starts adding values of pi. Why am I going over all of these different ways to give answers? Well, different problems call for answers in different forms, right? This is exact, this makes it infinite. This is approximate, this makes it infinite. This is also approximate, this also makes it infinite, but this gives us a positive answer, so that if we need our answers from 0 to 2 pi, we would give this one and then add another pi value to get our quadrant 4 angle as a positive angle instead. So just understanding that there's different ways to write the answers to fit the specifications, and just because your answer doesn't look exactly like the answer key does not mean that you are wrong. You might just have a different version of the answer. Okay, last one, question 3. First thing we need to do with question 3 is change this to cosine instead, because we're more familiar with cosine. Our calculator may not even have an inverse secant on it, right? We talked about that before. So we're going to use cosine instead. So let me change this to a cosine problem just right off the bat. Instead of secant x, it's going to be cosine x equals negative 3/5. We have not changed the answer. Yes, we changed the problem. We have not changed the answer because we switched it to a different trig ratio and switched the ratio to go with it. Okay, so that means our answer will be the inverse cosine of negative 3/5. So that will give us our quadrant 2 angle plus 2 pi k. So that one's quadrant 2. But we also need a quadrant 3 angle, because of course we know all students take calculus, so cosine is negative in quadrant 2 and 3. Now this is tricky because remember how for other problems like this one right here, we did pi minus that reference angle in question, or in quadrant 1 to find the quadrant 2 angle. So even though this angle is a quadrant 2 angle, if we use a positive 3/5, that makes it a quadrant 1 angle with the same reference angle. And that way we can do quadrant 3 just by subtracting it from pi, just like we did in question 1. So I hope this makes sense, but I can just do this by going pi minus the inverse cosine of positive 3/5, because that would be the quadrant 1 reference angle. Ooh, I'm getting that wrong. That would be quadrant 2. So what I'm doing is trying to put that in quadrant 3 by taking pi and adding that reference angle to pi for my quadrant 3 angle. Hope that makes sense. I said it wrong the first time around because subtracting it gives us a quadrant 2 angle like it did here. Adding the reference angle would give us that quadrant 3 angle. Plus 2 pi k, and that's our quadrant 3 angle. So now if we want approximate answers, we can plug that in, so we get the inverse cosine of negative 3/5. And that would be, I did something wrong. There, I got it. So that would be 2.2143, round the 9 rounds the 2 up to a 3, plus 2 pi k for quadrant 2. And then for quadrant 3, we could just do pi minus that reference angle, right? So we're just going to do that. So pi plus. I keep saying minus when it's plus because it's quadrant 3. So pi plus the inverse cosine of positive 3/5 to get the reference angle that's in quadrant 1. And that gives us 4.068, round the 8 to a 9. And there's our approximate quadrant 3 angle plus infinitely many other answers. So we have exact answers, we have approximate answers, And we've talked about this. Sometimes we just do answers from 0 to 2 pi, and we don't even bother with putting the 2 pi k at the end of our final answer. However, it's very good to get in the habit of doing that just in case you need to make sure you have all possible answers before you say, hey, these are my final answers between 0 and 2 pi. All right, that's it.